So in this session, we'll discuss about different energy resources, and main objective is how we can use these different forms of energies to generate electricity. So we'll discuss about different types of power stations as well. So first, the energy resources can be a renewable energy resource or it can be a non-renewable energy resource or energy source. Basically, renewable energy sources, what is the meaning or concept of renewable energy resource? Because what happened, like if you have any energy source, it is forming and you're consuming. So how you can identify that whether the energy source is a renewable or non-renewable? So you have to check this balance. Like example, if energy resource is forming more or rate of formation is more, but we are consuming or we are using less. So if it is forming at a greater rate and we are consuming less, it means that kind of energy source is known as renewable energy resource. So energy source can be a renewable or non-renewable. So simple way to identify whether an energy source can be a renewable or non-renewable, that's a simple technique. So if any kind of energy source is there, what you check, you will check two things. One is forming, the rate at which it is forming, and the second one, the rate at which we are consuming or we are using it. So if we find that it is forming at a greater amount, but we are consuming very small quantity of it, so we call that energy resource as a renewable energy resource. An example of renewable energy resource, like example, the solar energy from the sun. Solar energy is renewable. Why it is renewable? Because sun is producing enormous amount of energy. But what we are utilizing very small part of it. That's why we call the energy from the sun is a renewable energy source. But what is the meaning of non-renewable energy resource? If energy source we are consuming more, so two things are there for energy resource. One is the formation because it is always forming, and another one is consumption. We are using it. So if the energy source we are using more or we consume more, but it is forming at a slow rate, or so that kind of energy resource, that is known as non-renewable energy resource. Means a time will come when this energy source will deplete means a time will come when this energy source will completely used up. So example, like coal, oil, gas, these all are non-renewable energy sources. Why we call them as non-renewable energy sources? Because we are using too much coal for production, but it is forming at a, or we are utilizing too much coal for this as a source of energy, but it is forming at a very slow rate. So a time will come when we don't have any reservoir or any amount of coal left, so that energy source will deplete or completely used up. Is it clear the concept of renewable and non-renewable energy sources? Any question or doubt here? Why non? It's not about bad or good. Why non-renewable? Because non-renewable energy resources, a time will come when you're not left with any source, so you cannot produce energy. For example, we are using petrol. So petrol, or we are using a crude oil as a different source of energy. So the amount of crude oil which we are using every day and the amount of crude oil which is formed, that is having a big difference. So a time will come. So a time will come when we are not left with energy. We are not left with any crude oil or the fractions of the crude oil. So we call that energy resource as non-renewable energy resource. So example of renewable: solar, wind, hydroelectric, geothermal. We'll discuss about geothermal as well. An example of non-renewable, such as coal, fossil fuels, nuclear fuels. These all are non-renewable. A time will come when we are not left with any amount of these fuels. So that's why we should shift our balance to non-renewable energy resources, such as generating energy from solar, wind, hydroelectric, geothermal, rather than coal, oil, and nuclear fuels. Any question or a doubt? Yes, Abdullah Sarfraz, is it clear? Saim, Abdullah Khan. So the simple concept: renewable energy resources are that can be replenished over a short time, means that can be produced over a short time. So it can, in a short time, it can be produced, but a source which cannot be produced in a short time, or that cannot be replenished in a short time, we call that as non-renewable energy. So examples of renewable: solar, wind, hydroelectric, geothermal. Example of non-renewable: coal, fossil fuel, and nuclear fuel. Now, generating electricity using renewable energy. So we can produce electricity by using a renewable energies such as solar, hydroelectric. So first one, solar energy. How we can produce electricity from solar energy? So maybe you have seen these solar cells, the solar panels. So what happened? These are the solar panels or solar cell. When the light, basically heat and light from the sun is producing both heat and light. So it is producing both heat and light. When this light falls on the solar cell or a solar panel, what it produces? It produces charges. It produces electrons. And these electrons can move in the circuit, or these electrons can move in the wire. So we can use these electrons to generate electricity. So as you can see here in this picture, so the heat and the light energy is there from the sun, which fall on this panel. Solar PV system means it's a polyvoltaic system called PV system, or you can also say solar cell. So what is the difference between solar cell and panel? Solar cell means it is one, but solar panel means like many cells are together. So when many solar cells are together, we call that as a solar panel. So what you see here, it is a solar cell or solar panel. Many cells are together. So what we call this? So because there are many cells together, so we call that as a solar panel. So what happened? The heat and the light energy from the sun, as it falls on this solar panel, So what it create electrons, and these cells are connected with wires. So you can see here the movement of electron, the yellow shade, the yellow lines are representing the movement of electron. So as these electrons are moving, what we can do, because directly we do not use it, so we can store this energy in a battery. Why we store this energy in the battery? Because we want a constant output, because sometime if the weather is sunny or a cloudy, it will have different result or different output. So for, it's not like directly when it produces electron, we do not use that energy directly. What we do, we store it in a battery, and then the battery supply the energy to different parts which can be utilized by consumers. And what is the meaning of inverter here? Because there are two types of current that we will discuss in block 4. DC means direct current, and AC means alternating current. We'll discuss the difference between direct current and alternating current in block 4. So I'm not going in detail of AC and DC. So a device which can convert one form of a current to another, that is called inverter. So we use inverter to convert one form of the current to another. And what is the purpose of converting here, that same all the details we will discuss in block 4. So right now what is important, that you should understand the fact. So when the light from the sun falls on the solar panel, what it produces electron, and these electrons we store first in a battery, and then we use the energy from the battery to produce electricity. Is it clear, this concept of a solar cell? Any question or a doubt? You can use the chat or mic if you have any doubt. So when we compare these solar cells, what are the energy conversions that take place? So first, heat and light energy. You can write light and heat both. Not only heat, not only light, it's actually both. Heat and light energy from the sun. We can also say solar energy. And that directly converted into electrical energy. So heat and light energy from the sun, when it falls on the solar panel, it produces electrical energy. And what is a block diagram? Block diagram means the devices, the components which we are using. So what we use a solar panel, and we use a transformer. What is a transformer? Basically, in electricity transmission, we always use a transformer. The purpose of the transformer is to make a constant voltage. So what we will have in between them, in this figure you don't see a transformer, but whenever we produce electricity, and we transmit electricity or transfer electricity, so from production to transfer, what is there in between them? There are transformers. What is the purpose of the transformer? The transformers are making a suitable voltage for the devices. Like you will find on some of the devices it is written 220V. So what these transformers are doing, these transformers are producing a fixed voltage so that we can use the specific devices. Even your mobile charger, is also a transformer. How your mobile charger is a transformer? Because the socket on which you plug in the charger, that socket is having 220 volts or 240 volts. But for charging of the mobile, your mobile only needs 6 volts, or some of them are 9 volts. So it only need 9 volts to work. So your mobile only need 9 volts to charge, but the main supply, the socket is providing 220. So what you do, you plug in the charger. So actually the charger, your charger is a transformer. There is a transformer inside the charger which transform the voltage. It take 220 and it converted into 9 volts. So inside the charger there is a transformer. So whenever we are using electrical appliances or devices, we have these transformers. So same thing for transmission of electricity, to make the voltage to different values, we use transformers. Is it clear, the concept of the transformer in electrical transmission? So whenever there's anything related to electricity, even your mobile, your laptop, if you are using a laptop, so you will find the charger there. So when you plug in the charger, there is a rectangular box. What is that rectangular box? Actually, that is a transformer. So same thing, your laptop, it only takes 6 volts. It only needs 6 volts. But when you plug into the socket, it is providing you 220 volt. So there should be a transformer which transform the 220 volts to 6 volts. Otherwise, if without a charger or without an adapter, if you directly plug in your laptop, it will blow because of very high voltage. So it can damage the component. So whenever we are transferring the block diagram, we use solar panel and we use transformer because we want to transform the voltage. Now, what are the advantages of these generating electricity by solar panels? It is having a low running cost. Like, you don't have to buy any fuel here. So it is having a low running cost. You don't have to put oil, or you don't have to maintain the cell. Once you place, it will be there for 10 to 15, either for 25 years. You don't have to maintain. Battery should be maintained, but not the solar cell. No major pollution. It does not create any kind of pollution, like does not produce any harmful gases. And it is a renewable energy source, so means it is available all the time. You can utilize easily. But what are disadvantage? Low efficiency. What is the meaning of low efficiency? Like, the energy which is generated by these cells, it is very small. Like, one cell or one solar cell is only producing, example, 6 volts. Or if group of cells are there, maybe 12 volts. So that electricity which they are generating, that's very small amount. So it does not produce a large scale. And if you want to produce a large scale, then what you should do, you should attach so many cells should be there to produce greater amount of energy. So if one cell, one solar cell or one panel cannot generate enough energy, so there should be lot of panels, and it covered the large area. When we set up this solar system, solar panel, we have to use a lot of space to put these panels. Availability varies. What does it mean? Solar cells are not readily available in different regions of the country. Like some of the countries, as they are manufacturing, you can find solar cell easily. But some countries which are not manufacturing them, so the initial cost of solar cell is too much, or you don't find it very common. An amount of current produced by solar cell is usually too small, so it needs a large amount. It to small devices, so that need large amount of electricity. So, like example, if I want to use energy directly for air condition, AC, So directly I cannot use the solar cell. Why I cannot use a solar cell? Because the electricity which is generated by this solar cell is very small. So I cannot directly plug in or directly connect the solar cell or solar panel with AC or air condition. It will not work. First, what I have to do, I need large battery to store that, and from the battery it will transfer that to air condition. And it is not reliable. What is the meaning of not reliable? Because what happens if you have a sunny day, you will have more energy, solar energy available. But if you have a cloudy weather, a forecast, so in that case, what will happen? It will not produce enough energy. Why we should use battery? Because this solar cell directly produce a very small amount, so we have to store it and then utilize. As you can see here, example, this is producing 12, this panel is producing 12, this is producing 12, this is producing. So total will be 36. But that 36 is not sufficient. That 36 volt is not sufficient to work any electrical device. So first we have to store for a longer period of a time to the battery until the battery voltage reaches example 220, and then we utilize in our home. If directly it is plugged in and it will not work properly, why? Because for example, the maximum voltage this solar cell can provide is 12. But if it is a cloudy, the weather is cloudy, then what will happen? Amount will decrease. Now it will provide 6. So the voltage output will decrease. So we cannot directly connect them to device. First we have to store the energy in battery, and from the battery we will utilize, so we get a constant energy. Is it clear the concept of solar panels, how we can use it to generate electricity? Any question or doubt? Is it clear, Abdullah, why if we don't use battery, it will not be efficient? So this is how we can generate electricity by the renewable energy source, which is the solar. The second way, what we can do, we can use hydroelectric energy. What is a hydroelectric energy? From the name you can understand, hydro means water and electric here from electricity. So first what we do, as you can see in the picture, we store the water. This is called a dam. So we store the water behind the dam, as you can see. Then what we do, we open these gates for the dam. So the moment we open the gates for the dam, the water will start to flow. If the water is stored behind the dam, when we store this water behind the dam, so which form of energy it is having? Which form of energy? Electric, kinetic, potential. When the water is stored behind the dam at certain height, which form of energy this water is having? That is potential. That's good. Gravitational potential or potential. Then what we do, when we open these gates of the dam, the water will start to flow. So when the water is moving water, which form of energy it will have? Kinetic. Potential and kinetic, that's good when it is moving because it is already at certain height. But at the last moment when it is on the base, it will have kinetic. Then what happened? This water rotate the turbine. This is a turbine. And whenever the turbine rotates, what it produces? It produces electricity. So when the water move or rotate this turbine, when this turbine rotate, it produces electricity, and we use a transformer to convert the electricity into certain value, and that is transferred to us. So this is how a hydroelectric power station works, that we store the water behind the dam, and we allow the water to flow. So as the water will flow, it will rotate the turbine, and when the turbine rotate, it produces electricity which can be transformed into different voltages by using a transformer. Is it clear? The concept of hydroelectric energy. To everyone, anyone having a question or a doubt related to hydroelectric? This water, how this is what we do, we stop the flow of the river or the lake and we trap this water. If this water normally, because it is the dams are built on the rivers and lakes, so and rivers and lake, the main source is of water which is coming to rivers and lake is the rain. So it can vary sometime. If we have like too much rain, then the water level will be much higher as compared to in a case of drought. So this level of the water may vary depending on the amount of rainfall in that specific year. But the main concept, we store the water behind the dam. So continuously, because it's a river or the lake, so the continuously the water is coming. For example, if that region, if it completely stop raining for some several years, then this dam, the water of the dam will be used up. No more water will be there. But because it is built on the river or the lake, which is the source of a fresh water, and fresh water source is the main, like through the rain it is coming out. So time to time it fill up this dam. So it rarely happen that the water consumed completely used up in the dam. Because once the water is used, allowed to flow, then it's because it's a continuous flow of the water, so water is coming back into the dam by different valleys and through the rain. Is it clear? This concept of hydroelectric? Then what are the energy conversions that take place? So first, because the water which is stored behind the dam, it will have potential energy. Then this water start to flow, so this will be a kinetic energy of the water. Then that is converted into mechanical. Mechanical means kinetic energy of turbine and generator. Because we have turbine, and with the turbine it is connected a generator. And then from generator it produce electrical energy. So this is the energy change. Potential energy of water changes to its kinetic, and then kinetic energy changes to, you can also write here kinetic energy of turbine and generator. And when generator turbine rotate, it rotated the generator coil which produce electricity. What is a block diagram? We use dam here to store the water. We use turbine, then it is connected to generator, and then generator is connected to transformer. Then what are advantages? It's low running cost. Low running cost means you don't have to buy fuel for hydroelectric. Continuously the water is flowing and you can generate electricity. And it is the cheapest way of generating electricity. There are different methods to generate electricity, but this is the cheapest way to generate electricity. But what are disadvantages? Disadvantages: building a large dam causes a flood in a vast area. So basically, what happened? As you can see, as this dam is built, so the vast area is flooded. So this area initially it was having water, but not that too much water. But this vast area, maybe first before building the dam, the water was flowing in this manner because it was a river. But when we build this wall, what we stop the flow of the river, so the water spread in the surrounding area. So large area of the land is flooded with water, which cannot be now suitable for growing. It's now not suitable for growing plants or crops. And why it is a cheap here? We don't have to buy water here. We just have to build the wall to stop the flow of the water, and as the water flow, it will generate electricity. So that's why it is cheap. You don't have to buy water. It's just you have to trap the water, the flow of the water, and you can generate electricity. High building cost. Why high building cost? Because you have to build the wall, and it is difficult to build the wall in water. So that's why it is having a high building cost, and it destroy the natural land area. Because first, what happened? If there was a river which was flowing, it was taking a very small, like having a small width. But when you create a wall or a dam, so when you build this dam to stop the flow of water, so what will happen? The side where the water was coming, that side, the amount of water will surrounding will increase. So that's why it will destroy the nearby land area. This is like a top view, looking from the top. This dam. Is it clear the concept of hydroelectric power station? Any question or a doubt? So basically, sometimes they ask how the water is stored behind the dam. So basically, it's a water cycle. If the question is how water is stored behind the dam, so how we can store the water behind the dam? So it's like the water cycle which you have studied in the lower classes. So heat and light energy. This is a large body. There is evaporation in river also, and there is evaporation in sea. But because we have greater amount of sea as compared to fresh water, so the heat energy basically from the sun is absorbed by the water, and when this water absorbs this heat energy, it will turn into water vapors. So water will turn into vapor and it will rise. And when these water vapors will rise, they will condense to form clouds. And when these clouds move from one place to another and it rain at a higher altitude, as it rain in the valley or higher altitude, so the water start to flow. And as this water start to flow, what it will form? It will form a river, river and lakes. And then this water which is flowing, what we do? We build a wall, which we also call a dam. So we build a wall to store this water behind the dams. So basically, it's a water cycle. Apart from a water cycle, that heat energy from the sun absorbed by the water in the sea which convert the water into vapors. These vapor rises and condense to form clouds. And when it rains from the clouds at higher altitude, the water start to flow, which will form river. And we build the wall or we build a dam to store the water behind the dams. Is it clear? The concept of how water is basically stored behind the dams. So even what is the source of hydroelectric? The source of hydroelectric is the sun. Because if we don't have sun, the water will not rise. There will be no rivers or lakes. So the main source of this hydroelectric power station is the sun. So without sun, we cannot have hydroelectric power stations. So I'll share another link and discuss more about different power stations. Any question till now? So I'll share another link and continue this discussion.